Plot points in a coordinate plane. So what a coordinate plane is, it's actually kind of like two number lines. One that's going to be horizontal, that's called the x-axis. Then one that's going to be vertical, and that's called the y-axis. And where they cross, right here, that's 0, 0. That's called the origin. And that's a really important point because it's where everything starts, both the x and the y coordinate. So let's look in a little bit more detail here. What it has here is there's the points in the coordinate plane. Everything that's here is going to be positive for x because x always goes first. So it's x and then y. So it's going to be positive for x and then positive for y in that first quadrant. And it's labeled with Roman numerals. That I don't know why. For quadrant 2, it's going to be negative x because we're going to the left. And then we're going up, so it's then positive y. For this one here, for quadrant 3, we're going to the left from the origin, so that's negative. And then we're going down, so that's negative again. Again, all this here is just the direction from that part there of the origin. And the final quadrant is going to be this one right here, which we are going to go to the right from the origin. So that's going to be positive. And then we're going to go down, so it's then negative. So that's how each of those work. Let's look at a couple of examples of this. So right here, this one here is 3 over and then 2 down. So 3 over, then 2 down. 3 over to the right. This one here is a little bit trickier because what it is, a lot of people it's harder. It's actually easier because you don't have to move as much. You go left, right first. How many do you go left? You go left 4, so that's going to be negative 4 when we go left from the origin. It's a negative number. When we go right, it's a positive number. Then do we go up or down at all? No, we don't, so it's just then 0. So now looking at these examples here, it says give the coordinates of the point, point A. In this case here, we start again at that origin right there. We go over 3, 1, 2, 3, and we're going to the left. And then we're going up 4, 1, 2, 3, 4. So that's why it's negative 3, 4. The next one is going to be this point that I need to cover up now, or erase there. The next one is going to be B. And here we're going 2 to the right, so that's positive 2 in the x coordinate. Remember, we always go x first. And then we're going to go down 3, so that's going to be negative 3. For these examples here, we're just going to look at those closely or quickly. It says here, use the coordinate plane in example 1 to give the coordinates of points C, D, and E. So let's look at these here. Remember, it's x and then y. That's what we've got to do. So it says here, for point C, that's going to be right there. Do we go left and right at all? No, we don't. Not from the origin. Again, the origin is right here. So do we go left and right at all? No, we don't. So it's just 0. Do we go up or down at all? Yes, we do. We go up 2. So that's point C. That's it. So now let's look at point D. We again start at the origin where the x and y axis cross. Then we count over. We're going to the right, so it's positive, and it's going to be 3 over to the right, so positive 3, and then it's going to be up 1. So that's going to be point D. And the last one is point E, and in that case there, I'm just going to erase this a little bit since I think you get the idea of the origin. So now what we're going to deal with is we're going to go to the left 1, 2 spaces. So that's going to be negative 2 because we're going to the left. And then we're going down 1, 2, 3. So it's negative 3. So that's going to be E. And that's it. So in terms of plotting points in the coordinate plane, that is, we're just going to go ahead and count from the 0. It's kind of what we were just doing. We're going to count from the origin, the 0, 0 point, and just go up and over or down, or you always start left, right, and then you go up, down, because that's the left, right is the X, up, down is the Y. So what we do for point A, it's going to be negative 4, 4, so we start at the 0 point right there again, and we count over 4 to the left, and then we go up 4, and we're there. That's the reason why it's right there in terms of graphing the point. The next one, for B, it's 3, negative 2. So it's, in this case here, it's going to be 3 to the right because it's positive, and then 2 down. So that's why it's negative 2. And the last one that's listed there is problem C. That's going to be 0, negative 4. So we don't go left, right at all. We just go straight down from that point right there. We just go straight down from there. When we do that, we end up with this point right there. So in terms of graphing a function, now we're going to get into how functions work and graphing them. What's going to happen is you're going to make a table. It says here, graph a function for these values of x. With the domain, remember the domain is going to be the x value, of negative 2, negative 1, 0, 1, and 2. So all we're going to do is we're going to come up with a chart like this. We're going to list the x first. And so it's negative 2, negative 1, 0, 1, and 2. And then we're going to plug it into the equation. That's what this step is right here. Plug it into the equation. We're just substituting the value negative 2 for x into the equation y is equal to 2x minus 1. So we're just substituting in negative 2 there. And when we do that, 2 times negative 2 is going to be negative 4 minus 1. We're going to do it the way that I've taught already. Plus negative 1. And then we end up with y is equal to negative 5. And then what we do is we take that point and we plot it. The point that we plot is going to be the x value of negative 2, the y value of negative 5. And so that's why that first point is right there. And then we do that for all these other ones as well. For negative 2 and negative 1, it's right there. For negative 2 and 0, that one's my favorite. It's the easiest one because you're multiplying by 0. It's also important for a couple of reasons that we'll get into later. As a matter of fact, we already mentioned that's where it crosses the y-axis. That's where the 0 value of x is, and that's important. Then we have the final 2 right there. And so that's what it looks like here. And since you have a nice straight line, you're probably doing well and right on track. So I drew a coordinate plane for these examples here. Plot the point in the coordinate plane 2, 5. So all I'm going to do is I'm going to start again at that origin. 2 over, 1, 2 over, and then 5 up, 1, 2, 3, 4, 5. And that's going to be my point right there. So that is how you do this, just as an example here. So for the next one here, okay, continue here. Start at the origin again. You still have to start at that point, the 0, 0 point. Negative 1, 0, negative 1, right there. And then 0 up or down. So that's going to be point B right there. This is point A. Point C is going to be negative 2, so 1, 2 over. And then 1 down, which is going to be point C, so that's point C. Point D is going to be negative 5, 3. So it's going to be 1, 2, 3, 4, 5 over. That's 5 to the left. And then 3 up, 1, 2, 3. So it's going to be right about there. That's going to be point D. Now we're going to go ahead and graph this next one. So I went ahead and I have now written out the formula and got rid of that picture. That's the actual equation that we're going to be graphing. And we're going to be graphing it for the following values of x. So what I've written out here is I've substituted in the values for x into the equation. Now we're just going to solve them. Negative 1/3 times negative 6 is going to be, well, that's going to be positive 2. Because negative times a positive, and then positive 2 plus positive 2 is going to be 4. Then negative 1/3 times negative 3, that's going to be 1. 1 plus 2 equals 3. Negative 1/3 times 0 plus 2, that's going to be 2. Negative 1/3 times 3 is going to be negative 1 plus 2 is going to be 1. And then negative 1/3 times 6 is going to be negative 2 plus 2 is going to be 0. So now what we have to do is this is going to be the value of y, and then we have x, and so we just have to plot the points now. So it's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 over, and then 1, 2, 3, 4 up. That's going to be that first point there. And I like to actually write these out. So 6, 4 is that first point, or negative 6, 4 is that first point. The next point is going to be negative 3, 3. So negative 3, 1, 2, 3, 1, and then 1, 2, 3 like that. And that's going to be 0 and 2. It's going to go right there. 0 and 2. Then we have 3, and then 1, and then 6, and then 0. So 3 and 1, it's going to be 1, 2, 3, and then 1 up. And then 6, it's going to be somewhere over here. It's going to be right about there. And it looks like a nice line, so it all is good. So the next problem, it's going to be dealing with graphing functions that have a table. And here it's talking about the 19th Amendment, giving women the right to vote. And starting with the year 1920, and it's looking at the amount of votes that people cast, and obviously it went up substantially. Year 0 is going to be 1920 when women first got the right to vote, and suddenly 8 million more people voted, and then it just kept on going from there. Yeah, the population was growing, but still much bigger. So now here is what's going to happen here with this solution. We're just going to go ahead and plot the points afterwards, and that's the graph you're going to end up with. In this case here, if you notice, each of the changes is going to be 4. Each of the intervals is 4. That's how you can fit the whole thing on the graph. And now we're going to do an example with this one right here with that. Same sort of idea here. Here they're talking about when presidential elections in 1972 was the first election where 18-year-olds could vote. So that's the year when 18-year-olds got a chance to vote. And suddenly the voting went up pretty substantially. So it says here the presidential election in 1972 was the first election in which 18-year-olds were able to vote. The table shows the number to the nearest million of votes cast in presidential elections, both before and since 1972. So that's what it is, and then we're going to graph that. It says here, explain how you know the graph represents a function. Well, the easiest way to recognize that is that there is no value in the domain, this line here, that is the same. And giving a different value for the actual range, which is going to be the second one. So that's the way that you can determine that it is actually a function. So now it says graph the function. I'm going to do that quickly. So what I had to do is I had to label the graph so that along the x-axis it goes up by 4. or down by 4, depending upon whether you're going to the left or to the right. And on the y-axis, it's going up by tens. So let's see where these points end up. So that's how the graph should look if you plot the points that way. You can see it's not exactly straight, but it goes up a little bit more as you go from left to right at the end. So that would be our trend. We'd notice that towards in the year, let's see here, year 12, which would instead be the year 1984, that actually there were more people than you would have expected if it was just a straight line going from left to right. It started off kind of a connect the dots in a straight line thing here, but then it ended up going ahead and going a little bit higher there. So the number of voters was increasing. That's basically the trend.